Hello there. I'm Sammy Burke of New World Cartographic in Chicago, Illinois, and I wanted to try something new here. We're going to do a short little video in which we feature one of the maps in our upcoming newsletter of new listings. Now, the map we're going to do today is currently one of my favorites, and that's primarily because of a background that I have in climate science, studying it as an undergrad. This map is fairly new, well, newer than most of the material that we have here. It's out of the 1930s, and it was done by a gentleman by the name of Justus Perthius. The map is titled Die Atmosphäre der Erde, which essentially means the atmosphere of the Earth. Now, this map, as I mentioned, was done in the 1930s, and it was compiled with the data and the climate system model used by Rudolph Geiger. Now, Rudolph Geiger was a German meteorologist and climatologist, and he worked with Vladimir Köppen to develop a climate classification system which is still widely used today, and that climate classification system is on display in this map. You'll notice number 12 after the title. This map was part of a large series of other maps that detail various aspects of the Earth's climate, but this one focuses on atmospheric perils. Now, what are atmospheric perils? They are essentially disturbances in the atmosphere or otherwise the oceans that can more often than not cause natural disasters. Now, in this map, we notice lots of colors, lots of indicators, arrows, symbols, and we're going to dive into all of this. So first, I'd like to start by referring to the chart below, and that is the bicolor chart depicting correlations between hot temperatures and humidity. The pink refers to areas of very high temperatures, and the purple refers to areas with high humidity. The darker the color, the increase of each one. So for the purposes of examining this, let's focus in on Africa. You'll notice first that the dark purple, the area of mean annual maximum temperature, runs clearly along the equator with deviations north and south. As we look into Africa, we notice all these little dots. Some dots are small, some dots are large. Those dots represent mean annual numbers of days with thunderstorms, with the small ones being 60 to 120, and the large dots 120 and more. Now, as we look at Africa, we notice that in Sahara, it is extremely hot in Western Sahara, as identified by the dark pink. And as we go down towards this, the coast of New Guinea, we find that there are areas of high humidity. Now, you correlate these two and you get a band of thunderstorms. But as we go further into the continent, we pass the Congo River Valley and we get to the Eastern Ridge Mountains, where Lake Victoria and Kilimanjaro are located. We notice that there's an area of high thunderstorms, yet the humidity and the temperature is not so great. This is essentially showing the increase in elevation that correlates to an increase in condensation and thus rainfall, which then feeds the mighty Nile River. So just an interesting view at an area of this map that shows all these different climate elements that, when you pull them together and really look at them, tell you a story about what's going on in Africa and just the general geography and landscape of the continent. Next, we will turn our attention to these red arrows that we find. These arrows represent tropical hurricanes and cyclones. And as we notice, they all tend to run from east to west. This is a result of the Coriolis effect, which also shows them bending clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. Now, as we examine these areas, let's focus on North America, and we see those most common tracks of the hurricane. We also notice one of the tracks from that Hurricane Dorian actually followed, the one that just recently devastated the island of Grand Bahama and Abaco. And we see that it took the path that we had just seen back, what was this, in October, I believe, where it comes right up the coast and just misses and then spreads out to the northeast. The thicker arrows represent more than 20 thunderstorms or cyclones per year, and the smallest ones represent less than 5. Take a step back at the map to appreciate it a little more before we dive in, and this time we're going to start to look at the poles, the South Pole and the North Pole. We'll start at the Southern Pole, where we see Antarctica delineated with a black-red line, but then we also see these striped white and blue lines. The striped white and blue lines depict annual pack ice, essentially ice that rarely ever melts. And then you see all these other little shapes, and that most clearly represents seasonal pack ice and fast-moving ice, which in years past has engulfed and captured some ships, and many men had lost their lives because of this ice. We noticed back in 1930 that the ice extends as far north to just reach just a few hundred miles south of Tierra del Fuego, the southern point of South America. These, since we are down here, we notice these symbols that represent gale force winds, and then the yellow area, which represents area of high fog. These symbols are, again, a product of Rudolph Geiger and his additions that he made to the climate models that we have. Let's now look in the northern hemisphere at the Arctic Ocean, and we see that Hudson Bay and all of northern Canada is really filled with this seasonal pack ice. We also notice, if you look in close, the St. Lawrence, you see all these dark triangles, and that is essentially the southern extent of floating icebergs that come out of these areas in the summer when this pack ice melts away and it breaks apart. Notice this area of floating glaciers is also within areas of dense fog. And it wasn't just about 2 decades earlier, before this map was made, that the Titanic sunk right in this region over here. To cap things off, we'll focus a little bit closer to our home, which we are in Chicago, and we notice these striped lines. And those striped lines represent annual tornadoes. One set of stripes represents 20 to 60 tornadoes per year, and where you get the stripes going both directions, known as Tornado Alley, that is 60 or more tornadoes per year. So as we step back again, we notice all the colors, all the symbols. It's a highly involved map, but it's one that anyone can really understand and start to learn from as they decipher it using the key below. And we'll finish by scrolling across this key. So again, this is just a really fun map, especially if you like science, climatology. It's also, I find, really relevant to a lot of the issues we face today with global temperature rise and climate change, and what we're going to face in the future. Because essentially a lot of what this is showing is the natural disasters that were dealt with in the 1930s. It's a great snapshot of data from over 80 years ago of some of the most renowned studies of climate at the time. And it's just interesting to kind of correlate that with what we are seeing today. So that is it. Hope you enjoyed it for this featured map of our new listings. There will be more of these to come, especially if you like that. Feel free to comment below, ask any questions, and we will respond when we can. You can always visit us, of course, here in Chicago. We're at 1932 South Halstead Street in the Pilsen neighborhood, and happy to welcome you any day. Thank you, and have a good day.